Hello and welcome to our Precalculus final exam review video. In this video, we're going to be going over the practice final exam. Starting with problem number 1. Find the domain of the function, give the domain in set notation and interval notation. So the first thing we notice is that we do have a rational function. And at this point, you should know that a rational function has a restriction that the denominator cannot be 0. So we're going to have to find the restrictions and then we can write the domain. So the first thing we want to do is set up a quadratic inequality and solve for x. Next, to solve the quadratic inequality, I'm going to try factoring. Factoring may not work, but if it does, it is the fastest way to get the solutions. The signs are going to be different. We're going to have x and x to make x squared. And last, we need numbers that multiply to make 72. That subtract and make 1. That would be 9 and 8. 9 minus 8 is positive 1. Negative 8 times 9 is negative 72. And then I'm going to set each one of these factors not equal to 0. And then solving will tell me what x cannot be. Moving the plus 9 over, we see that x cannot be negative 9. And moving the negative 8, x cannot be 8. So to represent this using set notation first, we would say the domain is the set of all x such that x cannot be negative 9 or 8. And I want you to notice that set notation is super easy once you know the restriction. Next, interval notation is a little bit more exciting. Here the domain is everything from negative infinity to infinity, excluding negative 9. But including all of the values from negative 9 up to 8, excluding 8 and to infinity. So that's the way the domain would look in interval notation, and that does it for question number 1. Next, problem number 2, find the difference quotient. Notice the formula is not given. So for the difference quotient, we have f of x plus h minus f of x all over h. And then the first piece we need to figure out is f of x plus h. So that means we're going to go to the function and replace every x with x plus h. Negative 3x plus h squared minus 7 times x plus h. That's going to do it for f of x plus h. Then we have a minus, and next, the original function. Minus 3x squared minus 7x. That is all over h. And you need to write that every time. Next step. Negative 3x plus h squared means to multiply by itself. We're going to go ahead and distribute the negative 7 and the negative in front of the parentheses, giving us negative 7x minus 7h. Negative and a negative makes a plus 3x squared. And again, plus 7x all over h. And then the next step is to FOIL. First, outside, inside, last. That's going to give us negative 3 times x squared. I'm going to have a plus xh and another plus xh. So I'll have 2 of those. That's from the outside and the inside. And last, plus h squared. And then notice that the minus 7x and plus 7x cancel. So we're going to go ahead and eliminate those. And copy the other terms down. All over h. And now we can distribute the negative 3. Giving us negative 3x squared minus 6xh minus 3h squared minus 7h plus 3x squared all over h. And now notice the x squareds cancel. So carrying this up to the next step, we're going to have negative 6xh minus 3h squared minus 7h all over h. And notice in the numerator, all three terms have a factor of h, so we can factor it out. That will leave us negative 6x minus 3h minus 7. And this is the moment we've been waiting for where we can eliminate the h in the denominator. And so now our difference quotient result is negative 6x minus 3h minus 7. And that does it for question number 2. Next, number 3, write the quadratic function in standard form having a vertex of negative 3, 2. Just real quick, remember that is h and k. Passing through negative 1, negative 2, that is going to be a generic x and y. So since they gave me the vertex, I'm going to start with vertex form. And if you've forgotten what that looks like, that is f of x equals a, x minus h squared plus k. And then I'm going to plug and play. F of x is y. I'm going to replace that with negative 2 because I know y is negative 2. A, I don't know. X is negative 1. Minus h is negative 3. Minus a negative makes it a plus. 3 squared plus k is 2. And then we can solve for a. Negative 2 equals negative 1 plus 3 is 2. 2 squared is 4. A plus 2. Bringing the plus 2 over makes that a minus 2, which would give us a minus 4 equals 4a. Dividing both sides by 4 gives us a is 1. Now then, back to vertex form, we're going to have f of x equals a is negative 1 times x minus h minus a negative makes it a plus 3 squared plus k. And now that I'm in vertex form and they wanted standard form, I just need to multiply this out. So our function is f of x equals negative 1 times x plus 3 squared, means multiply by itself, plus 2. F of x is, now what I'm going to do next is I'm going to FOIL and distribute the negative 1 all at one time. Here we go. X times x, x squared, distributing the negative 1 makes it negative. I'm going to have a plus 3x and a plus 3x, making plus 6x, which becomes minus 6x if I distribute the negative 1. Last but not least, 3 times 3 is 9, giving me negative 9 when I distribute the negative 1, plus 2. One more step, and I'm done. We're going to have negative x squared minus 6x minus 7. And that is the answer in standard form. Next, number 4. A projectile is fired from a cliff 12 feet above the water with an initial velocity of 180 feet per second. The height of the projectile above the water in feet is given by, and then this is important, they give me the function, where t is the amount of time in seconds after the projectile was fired. Part A, at what time will the projectile hit the water? Well, we know h of t, the function notation, represents the height of the projectile above the water. When it hits the water, it's going to be at a height of 0. So we can answer this question by setting h of t equal to 0 and then solving the quadratic equation for t. So the first thing we need to do to solve a quadratic equation is set it equal to 0, which we have. And then the next thing we need to make sure of is that our coefficient of the squared variable is positive. So here the next step would be to distribute -1, which will simply change all the signs. And then my numbers will be ready to plug into the quadratic formula. So here we can see A is 32, B -180, and C is -12. And to the quadratic formula, we're going to have T is equal to -B, which would be +180, plus or minus the square root of -180 squared, minus 4 times A times C all over 2A. And then we need to grab our calculator to calculate this value. Here we go. In the class whiz, as a fraction, we're going to have 180. I'm going to do the positive first, plus the square root of -180 squared minus 4 times 32 times -12 all over 2 times 32, and that's going to give me an answer of 5.69. They want it rounded to the nearest hundredth, which is 2 decimal places. So that's going to give me 5.69 seconds. And then if we want to go back and do the negative, we simply pull up the calculator again. We scroll all the way back, and we're going to delete the plus, put in a minus. Notice that gives us a negative answer, but this is time after the projectile is fired, and you can't have a negative time. And so that answer is meaningless. So this is the answer for when the projectile will hit the water. Part B, when will the projectile reach its maximum height? Remember, if you're talking about the maximum or a minimum of a quadratic, you're really talking about the vertex. When means you're looking for T. And if we were to write these ordered pairs using T and H of T, T would be the X coordinate, H of T would be the Y coordinate. So they want to know when, which means we're looking for time, which means we're really looking for H. Remember, the vertex is H comma K. We want to find H. That is super easy. The formula for H is minus B over 2A. We know that B is 180 and A is -32. So minus 180 over 2 times -32. Using our handy-dandy class whiz to figure this out. Minus 180 over 2 times -32. That's going to be 45/16. Again, it says round to the nearest hundredth. So I'm going to hit the SD button, which makes it a decimal. That's going to be 2.81. And that's going to be seconds, rounded to the nearest hundredth. Part C, what is the maximum height? Well, now we're talking about K. What is the maximum height? That is the Y coordinate of the vertex. And we know that K is simply f of h. So we need to plug in the 2.81 from the previous step into our function and work it out. All right, so here I have written the function with every t replaced with the x coordinate of the vertex. We need to pull up our handy-dandy calculator to calculate that value. -32 times 2.81 squared plus 180 times 2.81 plus 12 And again, we need to round to the nearest hundredth, hitting the SD button. 265.12. 265.12. That is rounded correctly to the nearest hundredth. And the units in this case are feet. That is how high the projectile is at its maximum height. And that does it for this problem. Next, number 5, solve the equation. Notice it says give the exact solution in terms of the natural logarithm. And then we also need to find the approximate solution rounded to 3 decimal places. So here we have an exponential equation. The first step is to isolate the exponential part. So we are going to have to move negative pi to the other side, giving us e to the 3x minus 4 equals pi. And then, since the base does not have a coefficient, we can go ahead and stick a natural log on this side. Whatever I do to one side, I have to do to the other. Remember, once you have logarithms, you can access the properties of logarithms. I'm going to use the power rule to bring that exponent down and make it a coefficient. And then using our calculator if you need to, but you really should know at this point that natural log of e is 1. So that's going to give us 3x minus 4 times 1, but anything times 1 is itself, equals natural log of pi. And then 2 more steps, and I'm going to have my exact solution. Moving the negative 4 over is going to give me natural log of pi plus 4. Probably want to put the pi in parentheses so that you know the plus 4 is not part of the logarithm. And if we divide both sides by 3, that gets the x by itself. We're going to put a box around this. That is the exact solution. Now, to get the approximate solution to 3 decimal places, we're going to use our calculator. Using the fraction, natural log of pi, close parenthesis, plus 4, divided by 3, and rounded to 3 decimal places, 1.715. 1.715, and that's going to do it for question 5. Question number 6, solve the following logarithmic equation. Here I see that I have 2 terms that have log, and so what I need to do first is get them on the same side so that I can use the properties of logarithms in order to combine them. Now this log is negative, so bringing him over makes him a plus. Log base 4 of x plus 57 equals to 4. And now the 2 logs become 1, and we're using the product rule because we have a plus. Plus turns into multiplication. So the x minus 3 and the x plus 57 get multiplied. Again, that is the product rule. And now that I have this condensed to a single logarithm, I can convert to exponential. So we're going to bring the base down, switch the other 2 around, and I'm going to FOIL on the fly. X times x, x squared. On the outside, we have a plus 57x. On the inside, we have a minus 3x. And last but not least, 57 times negative 3 is negative 171. Now, look where I'm at. My log equation has now become quadratic. And since it's quadratic, I got to set it equal to 0. So we're going to move the 4 to the 4th over, and we're going to combine like terms, giving us x squared. 57 minus 3 is a plus 54x. And then negative 71 minus 4 to the 4th, using our calculator. Negative 171 minus 4 to the 4th negative 427. Okay, so now that I have my quadratic equal to 0, one of the techniques I could use to solve this is factoring. However, if you look at this last number, that is huge, and trying to come up with factors of 427 that subtract and make 54, that can seem intimidating. And so what I would like to do is show you that the ClassWiz has a cool feature that can help you. So on the ClassWiz, if you type in the number that you're trying to get to, you're trying to find factors of 427 and hit equals, there is a function on here called factors. That is shift and the degree, minute, second button right below the square root button. And what that does is it breaks your number down into factors. It actually gives you the prime factorization. So here I can see that the only numbers that multiply to make 427 are 61 and 7. And it turns out that 61 minus 7 is 54. So here the ClassWiz is very helpful as far as getting this to factor. And please understand that factoring is not absolutely necessary. You could have got the same result by completing the square or the quadratic formula. All right, so here we go. We're going to have different signs, plus and minus, x and x. Again, the numbers that multiply to make 427 and subtract to make 54 are 61 and 7, and the 61 has to go with the plus. And then if I set each factor equal to 0 and solve, moving the 61 over, that's going to give us x is negative 61. Moving the 7 gives us x is 7. And then we do need to check these solutions, plugging back into the original problem to make sure that they work. So what I want to do first is I want to check the negative value because I feel pretty confident that that's not a solution. Here we go. Plugging in, we're going to have log base 4 of negative 61 minus 3. And that's as far as I need to go, because that's going to make me take the log of a negative number, and that can't happen. And so that indicates that the negative 61 is not a good answer. And so then we're going to come back and check the 7. That's log base 4 of 7 minus 3 equals 4 minus log base 4 of 7 plus 57, which will simplify to log base 4 of 4 equals 4 minus log base 4 of 64. Now log base 4 of 4 is 1, and on the other side we can use the method of common bases, knowing that 64 is 4 cubed. And so here the bases match, so they cancel. That's going to give us 1 equals 4 minus 3, which checks out. And that means that x equals 7 is the only valid solution. And so that's going to do it for that problem. Next, number 7, find the exact value of the trigonometric functions. Here we are given a point in the coordinate system on the terminal side of theta. And so the first thing I want to do is I want to sketch a quick graph. So at negative 7, negative 8, we're going to have a point in the third quadrant, and then constructing a right triangle. Remember, the line has to go perpendicular to the x-axis. When you do that, this represents our reference angle theta. Our x value is negative 7. Y is negative 8. If I know x and y, I can get the radius. So r is the square root of x squared plus y squared. And given that a quick calculate on the calculator, negative 7 squared is 49. Negative 8 squared is 64. And notice that that does not square root nicely. So we're going to leave that in simplest radical form. And now that I know my radius, which is also the hypotenuse, we can find sine, cosine, and tangent. Okay, so from the unit circle, we know sine is y, but this is not a unit circle because the radius is not 1. So we're going to have to use the generic formula for sine, which is y over r, which would be negative 8 over square root of 113. And then notice it does say rationalize the denominator. So rationalized, that'll be negative 8 square root of 113 over 113. Next, cosine is x over r, which would be negative 7 over square root of 113. And again, we need to rationalize. Negative 7 square root of 113 over 113. And last, tangent, y over x. Y is negative 8, x is negative 7. Negative over a negative makes a positive, and we're done. Next problem, number 8. Find the amplitude, period, and the phase shift. Here we're given a cosine function. So we know for sine or cosine, the amplitude is the absolute value of the lead coefficient. That's going to give us an amplitude of 6. Next, the period for sine or cosine is 2 pi over b. B is the coefficient of x. So that's going to give us a 3. And that will not reduce. So that's going to be our period. Next, the phase shift is negative c over b. C is the constant added or subtracted to x. And again, b is the coefficient of x. So writing this out, that's going to be minus a negative. Do you see the formula has a minus? And c has a minus. Two negatives make a positive. Pi over 2 divided by b. Doing the keep, change, flip, that's going to be pi over 2 times 1 over 3, giving us a phase shift of pi over 6. And now that we know the amplitude, period, and the phase shift, we can graph this equation. We're going to follow our 6-step method for graphing sine, cosine, secant, or cosecant. And those steps are: step number 1, starting point. Step number 2, phase shift. Step number 3, wavelength. Step number 4, 4 spaces. Step number 5, lay out your points. And step number 6, connect the dots. So now that we have our steps listed, we're going to do step number 1, starting point, which means we have to go back to our function. And the starting point is determined by the trig function. We know that cosine starts at the number in front. So on the y-axis, we're going to go to negative 6. Now notice that the hash marks are not labeled. So I'm going to label these negative 2, negative 4, negative 6. And that's going to give me my starting point. Cosine starts at the number in front. Next, step number 2 is the phase shift. And if we go back up, remember our phase shift was positive, pi over 6. And so that means that this starting point that I just plotted is going to have to shift to the right a distance of pi over 6. Now notice that my hash marks are already labeled. And the labels are not going to work very well for my particular phase shift. So I'm going to relabel these hash marks. The first hash mark, I'm going to say that that is pi over 6, and that gives me a nice landing point for my phase shift. So we move the starting point to the right pi over 6 because that is step number 2, phase shift. Now before I go and do the wavelength, I need to label the rest of the hash marks based on my new unit of measure. So if one hash mark is pi over 6, the next one would be 2 pi over 6. And then if you just keep counting, 3/6, 4/6, 5/6, 6 sixths. And then to label those, we're going to reduce those fractions. All right, so here we go. Grabbing my black pen. 2 sixths is a third. And so this would be pi over 3. 3 sixths is a half. So this would be pi over 2. 4 sixths is 2 thirds. 5 sixths, well, doesn't reduce. That's 5 sixths. And last 6 sixths is pi. And so now those are the new labels of the hash mark. And now I can determine my wavelength. So scrolling back up, we know that the period is the wavelength. And that means from start to finish, I need to travel a distance of 2 pi over 3. And so then the question becomes 2 pi over 3 is how many pi over 6, because that's what each one of the hash marks represents on my graph. And real quick, we can figure out that that's going to be 4 pi over 6, because 4 sixths reduces to 2 thirds. And then this tells me how many hash marks I need to go from my starting point to get to my end point. All right, so here we go. Traveling 4 sixths. 1, 2, 3, 4. And you always finish where you start. So if I start at -6, I need to finish at -6. I would also like to point out that if we calculate now the distance from start to finish, since each one of these spaces is a sixth, that would be 4 pi over 6, which again is 2 thirds. So I know I have my wavelength correct. So now that we've got the wavelength, next we need to lay out 4 spaces from start to finish. And notice that I already have the 4 spaces from start to finish, so that is accomplished. And if you're wondering why the 4 spaces are necessary, it's because that's where your points go. And so now when it comes to lay out the points, I know if I start down at -6, at the next hash mark, I need to go to the x-axis, and then going to the next hash mark is going to take us up to +6. Next hash mark, we return to the x-axis, and finally back to -6. And then step number 6, if we connect the dots, we're going to get our nice, smooth cosine wave. And that is 1 period. Now, if I want to graph another period, I simply copy and paste this graph. And it doesn't matter if you continue the pattern right or left. So since I have more space to the left, I'm just going to continue the pattern. So here we go. Up, up, down, and down. And then connect the dots, and we're going to get another wavelength. So now we have graphed at least 2 periods of the function, and that does it for this problem. Next, number 9, we need to find the exact value of the expression. And the first thing I notice inside the brackets is an inverse tangent. Remember that an inverse trig function equals an angle. So we're going to pull this over to the side and set up an equation. So what I want to do first is I want to get rid of the inverse tangent. I can do that by bringing it back to the other side, which will make that regular tangent of theta equals 2 fifths. And the formula for tangent, remember, is y over x. And so automatically I know the values for x and y. Now if I need to, I can calculate the radius. That's going to be the square root of x squared plus y squared, which is going to be the square root of 25 plus 4, which is 29. And since that doesn't square root nicely, we're going to leave that in simplest radical form. And now we can take this value back to the original problem and find what they asked, the exact value of cosecant of theta. So remember, cosecant is the reciprocal of sine. So if sine is y over r, cosecant is r over y. Plugging in, we're going to get the square root of 29 over 2. And that is the answer for question number 9. Next, problem number 10. Solve the equation on the interval from 0 to 2 pi. And just to give you a little insight, if they say from 0 to 2 pi, that is an indication that they do want your angles to be in radians. So the first step to solve this equation, we're going to have to isolate the trig function since there is only one trig function, giving us 4 sine squared theta equals 3. Next, dividing both sides by 4, we'll have sine squared theta equals 3/4. And then to get rid of the squared, we can take the square root. So that's going to give us sine theta is plus or minus, and then we can take the square root of the top and the bottom separately. So square root of 3 won't square root, but the square root of 4 is 2. And now we can solve this equation knowing that in the unit circle, sine is y. So we need to find all of the angles where the ordered pair has a y coordinate of positive square root of 3 over 2 or negative square root of 3 over 2. And that means going to the unit circle. We're interested in a y coordinate of positive square root of 3 over 2 or negative square root of 3 over 2. And then those answers are going to be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And once we have all of those angles written down here, we're going to be done with question number 10. Question number 11. Solve the equation on the interval from 0 to 2 pi. Express solutions in radians. Again, if they tell us to 2 pi, that is an indication that our angles need to be in radians, and they want us to give the exact value. So in this equation, we have cosine of 2 theta plus 14 sine squared theta minus 10 equals 0. And I notice that I have a double angle for cosine, so I'm going to want to use a double angle formula. Since the other term is in terms of sine, I would really like to substitute for cosine of 2 theta something that is in terms of sine also. So going to our list of double angle formulas, we're dealing with cosine of 2 theta, and it appears that I really would like to use this particular formula because it is in terms of sine only. And so replacing cosine of 2 theta with 1 minus 2 sine squared theta plus 14 sine squared theta. And I'm going to go ahead and move this minus 10 to the other side. And we're going to combine like terms. Oh, and I'm also going to move this 1 now to the other side. So negative 2 plus 14, that's going to give us 12. Sine squared theta equals 9. Dividing both sides by 12, we're trying to isolate the trig function. 9/12 reduces to 3/4, and taking the square root, to get rid of the squared, we're going to have sine theta is plus or minus, and taking the square root of the top and the bottom separately. 3 doesn't square root, but 4 does. Remember, sine in the unit circle is y, so we want to go to the unit circle and find every angle that has an ordered pair with a y coordinate of positive square root of 3 over 2 or negative square root of 3 over 2. All right, going around the unit circle, looking for y coordinates of positive square root of 3 over 2 or negative square root of 3 over 2. That's going to give us 4 solutions. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that's going to do it for question number 11. Question number 12, they want us to solve the triangle. They give us two sides and an angle. I think it's probably a good idea if we sketch a quick picture to see what we've got. All right, so now that we have our picture sketched, notice that angle B is 10, and it's important to note that little letters go across from big letters. So little b would be across from big B, little c would be across from big C. And what I notice is that I am given only one angle that is acute, and the opposite side is less than the other side. So this meets the criteria for the ambiguous case, meaning that we are going to need to check to see if this particular problem has two sets of answers. Now the other thing we do need to notice is since we're given an angle and the side across from it, that indicates that we're going to be using the law of sines. So starting, we can say sine of angle B divided by side B equals sine of angle C divided by side C, and this will allow me to solve for angle C. Doing our cross multiply, that's going to give us 7 sine C equals 9 sine of 10. Dividing both sides by 7, we will have sine of C equals, and then to calculate this value, we need to go to our calculator. And making sure we are in degree mode, which we are, using our fraction button, we're going to have 9 sine of 10 divided by 7. And to keep our angle as accurate as possible, we want to round that to 4 decimal places. So 0.2233 rounded. And then to finish solving for C, we need to move over the sign. That will turn that into inverse sine of 0.2233. And then we need to input this in our calculator to get our angle for C. So inverse sine, that is shift and sine, 0.2233 works out to be 12.9. Now they do not indicate where to round to, so I'm going to choose to round to the nearest tenth for my angles, and that is 12.9 degrees. Now remember we said that this problem meets the criteria for maybe two sets of answers. So the next thing we need to do is find angle A and then see if there is a second set of angles. A1 is super easy. That is simply 180 minus the other two angles. So minus angle B minus angle C. And that's going to give us our first A to be 157.1. And again, that is degrees. Now that we have verified there is one set of solutions, we need to check to see if there is a second set of solutions. So if there is a second angle C, it's going to be 180 minus the first angle C, which was 12.9. And so C2, if it exists, is going to be 167.1. And now comes the point where we're going to see if there is actually a second set of answers. If there is a second angle A, it's going to have to be 180 minus the other two angles. So minus 10 minus 167.1. So if this calculation ends up being 0 or a negative number, we will only have one set of answers. And on our calculator, we did get a positive result. So there are going to be two sets of answers, and angle A2 is going to be 2.9 degrees. So that means there are also going to be two side A's. And the way we're going to calculate side A is, again, using the law of sines. We're going to say sine of 10 over 7, because it's good to recycle, equals sine of angle A1, 157.1, divided by side A1. And then if I cross multiply and divide, we're going to get A1 equals 7 sine 157.1 divided by sine of 10. And using our calculator again, 7 sine 157.1 divided by sine of 10. And I'm going to round that to 2 decimal places just because I feel like it, because they didn't specify. 15.69 rounded. And so that gives us side A1. Now, as a shortcut, side A2 is going to be exactly the same button pushes as side A1, except we're going to use A2. So instead of 157.1, we're going to use 2.9. And that means on our calculator, all we have to do is scroll back and delete angle A1 and insert angle A2. And again, rounded to 2 decimal places, 2.04. And that gets all of the answers for problem number 12. Question 13. Solve the triangle. Again, we might want to make a quick sketch of the triangle before we attempt solving. And once we have drawn a quick sketch, what you're going to notice is that we are given one angle and the 2 adjacent sides. Notice we do not have the side across from the angle given. That's going to indicate that this is a law of cosines problem. So we need to set up the law of cosines problem that will solve for C. And here we simply plug and play to find side C. So 13 squared plus 17 squared minus 2 times 13 times 17 times cosine of 41 degrees. All of this can be put into the calculator all at one time. And if you wanted to, you could probably even input that with the square root. All right, so inputting this all into the ClassWiz, including the square roots, we have square root of 13 squared plus 17 squared minus 2 times 13 times 17 times cosine of 41 degrees. Please make sure that you are in degree mode. If you're not in degree mode, you will not get the right answer. And then this is going to be our value for C because we did take the square root. It does not indicate where to round to, so I'm going to round to the nearest hundredth. That's going to be to 2 decimal places, 11.15. And if the instructions indicated where to round, you would need to round appropriately. Now what I'm going to do is put that back in my picture. And notice that I now have all 3 sides, which means that I can continue to use law of cosines in order to find angle A and B. So here I have written the formulas for the law of cosines in order to find angle A and B. And so all I need to do is plug in for the sides A, B, and C, go to my calculator, and I'll have my answers. Okay, so not to bore you with showing the writing all of those numbers plugged in, but I am going to demonstrate how we can input this in the ClassWiz all at one time to get our angle. Starting with shift and cosine for the inverse cosine. Next, we're going to use our fraction button and input the entire numerator, 17 squared plus 11.15 squared minus 13 squared, and then move to the denominator. We have 2 times 17 times 11.15. Notice I did not use the parentheses as I have them written. I just used multiplication symbols. You do need to move out of the denominator to close your parenthesis. And then that is going to be our angle for A. and I'm going to round that to the nearest tenth. They did not indicate where to round to, so I get to choose 49.9. And that's going to do it for angle A, and then I'm going to go to the calculator and do exactly the same thing for angle B. And that answer ended up being 89.1 degrees. Again, not boring you with the same button pushes. And that's going to do it for this particular problem. Number 14, they want us to plot the complex number in the complex plane. Notice that my axes are labeled X and Y. I don't know if you can see that or not, but we're going to scratch those out. In the complex plane, the x-axis is the real axis, and the y-axis is the imaginary axis, okay? So you can label those whatever you want. Just understand the x-axis is the real part, and the y-axis is the imaginary part. So to plot this number, this is going to work just like an x and a y, except we have our real part and our imaginary part. So we're going to go to the right 6 and down 8. That's going to give us a point in the complex plane. And then notice it does say to write the answer in polar form. And so lucky for us, we have formulas for that. Knowing that polar form looks like this, we're going to need to find our values for r and theta. R is the square root of a squared plus b squared. Remember, for a complex number, the standard form is a plus bi. So here we can see a is 6 and b is -8. Plugging into our formula, that's going to give us the square root of 36 plus 64, which is the square root of 100, which is 10. And that is the value for r, and we need theta. That formula is inverse tangent of b over a, which would be inverse tangent of b, again, is -8, a is 6. If we reduce the fraction, 8/6 reduces to 4/3, although that is not necessary since we're going to go to the calculator anyway. And reading the instructions, they did not indicate whether theta needs to be in radians or degrees. I feel like it's probably going to be radians. And so what I'm going to do first is I'm going to switch my calculator to radian mode. That's going to be shift and menu, the angle unit to radians. So now I've got radian mode. I can input the inverse tangent of -4/3, and that's going to give me -0.93 rounded. Now, one thing you should know about writing your answers in polar form, theta really should be positive. And if you notice, this angle is correct because if you look at where our point is plotted, this would represent a negative angle because we would start at 0 and spin clockwise to get into the fourth quadrant. And so my question to you is, if I have a negative angle, how do I get the positive equivalent? Well, that's not too hard. Really, if you think about it, if we're in the fourth quadrant and we want to return to the same location in the fourth quadrant, we simply need to add 360. But since we're in radians, we need to add 2 pi. So all I need to do is add 2 pi to this answer, and I will get the positive equivalent angle. And again, using our class whiz for that, we're going to start with 2 pi, and we're going to minus 0.93. Rounded again to 2 decimal places would be 5.35. And remember, this angle is in radians, so please do not put a degree symbol on that. Now that we know r and theta, we can go back to our formula and plug and play. So our radius was 10, and for theta, that was 5.35. And that's going to get us our polar form that we needed for the complex number. Now, as a special treat, I thought I would squeeze in some calculator counseling here. The calculator, the ClassWiz, does have the ability to calculate r and theta for you. If you hit Shift and the plus sign, what that will do is allow you to input your values for a and b, and it will calculate r and theta. 6, now you do have to use a comma, which is Shift and close parentheses, and -8. Notice that is going to give you the radius and the angle we asked for, which also means if you need degrees, you can simply go Shift Menu, change your angle input to degrees, and hit equals again, and it's going to give you the degree angle this time. So again, that's just a special treat for you guys using the ClassWiz. You are going to have to show all your work, but at least you can check it pretty quickly with your calculator. Number 15, they want us to find the cross product. Remember, the order of these vectors is important. So we're going to set this up to find the cross product. That's going to use a determinant where the top row is your I, J, and K. The second row has to be the first vector mentioned, and those are the coefficients of I, J, and K. And then the third row is the second vector mentioned, again just the coefficients for I, J, and K. And then you would need to evaluate this determinant. And I'm going to use my shortcut that I taught, which says you're going to copy and paste the first two columns to the outside, and then the next step says multiply down on the diagonals. First multiplication, -5 times -2 times I, gives us a 10I. Next, 2 times 3 times j is a plus 6j. And last but not least, 1 times 1 times k is a positive k. Then we're going to switch directions, multiplying up on the diagonals. And if you remember when I covered this in a previous video, I said when you change directions, you have to change the signs. So multiplying our first diagonal, 2 times -2 would be -4k, but I have to change the sign. Next, 1 times 3 times I would be positive 3i, change the sign. -5 times 1 times j is a -5j, change the sign. And then to get our cross product, all we have to do is combine like terms, adding the i's first. 10 minus 3, 7i. Next, the j's, 6 plus 5 is 11j. And finally, the k's, 4 plus 1 gives us a plus 5k. And that is our answer for the cross product. And again, taking just a few moments for the ClassWiz users. This is possible on the ClassWiz. If we go to Menu and then to the Vector app, we can define vector A. It is a three-dimensional vector, and the coefficients are 1, -2, and 3. And then we want to go back to Option. We do want to define another vector. So number 1, this time we're going to define vector B. Again, it is a three-dimensional vector. And this is the coefficients of W, which are 2, 1, and -5. And then if we hit Clear, go back to Option, we want to select vector A, number 3, and we hit the times button to indicate cross product. Back to Option, select vector B, and equals, and notice that is going to give you the coefficients for I, J, and K. So again, that's just a quick demonstration of how the Casio ClassWiz can verify your scratch work. Number 16, answer the following questions given a parabola. So we know we're working with the parabola. They give me the vertex and the focus. And what I want you to focus on is the fact that our x coordinates are identical. So we're going to want to go to our parabola information sheet and see which equation fits this particular setup. So at our information sheet, the equation that we're going to use is determined by which column has the vertex and focus with the same x coordinate. And notice that that is going to be column 1, where our x coordinates are simply h, indicating that they have to be the same, which means this is the equation we need to use. So back on my exam, what I've done is I have copied down the equation that I said we need to use, but I've also copied down the formulas we looked at for the vertex and the focus, because those are going to be needed in order to substitute for h, k, and p in order for me to complete the equation. So looking at the vertex, we can see that the value of h is 1, that is the x coordinate of the vertex. The value of k is -3, that is the y coordinate of the vertex. And to find p, we know that the y coordinate of the focus has to be -4. So we can say k plus p has to be -4, but we know k is -3. And so from that we can conclude that p is -1, because -3 plus -1 is -4. And now I can write my equation. X minus h would be x minus 1 squared equals 4 times p. 4 times -1 is -4. Y minus a negative will make that a +3. And that's it for part A. Part B, find the 2 points that define the latus rectum. So, doing a quick sketch of our parabola, knowing that the parabola has to enclose the focus, that means that this parabola is going to open down. I believe we also know that because p is negative. We know that the endpoints of the latus rectum have to be the points on the parabola that represent the line segment that contains the focus. So if we zoom in on our parabola that I've drawn here, we can see that the endpoints of the latus rectum would look like that. It has to be a line segment that is parallel to the directrix and at the same height as the focus. So to figure this out, we're going to be looking for the x coordinates of the points that have y coordinates equal to the y coordinate of the focus, which again, that is -4. So we simply need to plug -4 into our equation that we found for part A and solve for x. So that's going to give us x minus 1 squared equals -4 times y is -4 plus 3. Simplifying, x minus 1 squared equals -4 plus 3 is -1 times -4 gives us a 4. Taking the square root of both sides is going to give us x minus 1 equals plus or minus 2. And then if I move the -1 over, I'm going to be able to write my ordered pairs for the 2 points that define the latus rectum. Here we go. That would be 1 plus 2, which is 3, -4. Remember, that's got to be the same y as the focus. And that would also be 1 minus 2, which is -1, -4. And that is it for Part B. Part C, graph the parabola showing the vertex, the focus, and the endpoints of the latus rectum. So here all we need to do is plot all of the points we just got and sketch the graph. And so here I've tried to color code these points so that you know what's what. The red dot is the vertex, the blue dot right below it is the focus, and the green dots on either side of the blue dot, those are the endpoints of the latus rectum, and then we simply need to connect the dots. Remember, we got to go through the vertex and the endpoints of the latus rectum, and that's going to make a parabolic curve, and that's going to do it for this problem. Number 17, write the augmented matrix that represents the system of linear equations. Then perform the indicated row operations and write the new matrix. So for part A, we need to make sure that our equations are in the right format. All of my x's, y's, and z's lined up. And on the other side of the equal signs, we have the constants. And that means that this is ready to write the augmented matrix. Row 1. That's going to be the coefficients of the first equation. And remember, the word augmented means separated. So we have our separator that represents the equal signs. Next, row 2. Again, the coefficients of the second equation. Row 3, the coefficients of the last equation. And we need to close our bracket. That is it for the augmented matrix. Next, for part B, I have rewritten my row operations next to my augmented matrix, and we're going to perform both of those and write the new matrix. Notice the first thing is that rows 2 and 3 are going to change, so row 1 is going to stay the same. So the first thing you should do is just copy and paste the stuff that doesn't change, and then I have color coded these row operations, and so I'm going to try to help separate the work out by color. The first row operation, we need to multiply row 1 by 3. Whatever we get from that, we will then add to the corresponding element in row 2. All right, so here we go. First, we need to multiply 1 times 3, and then add that to the corresponding element in row 2. That's going to be 3 plus negative 3, which is 0. And then we're going to do it again. Negative 3 times 3, that's negative 9 plus 1 is negative 8. Again, 2 times 3 is 6. 6 plus negative 1 is 5. And last time, 5 times 3 is 15. 15 minus 10 is 5. And for the next row operation, now we're going to take row 1 multiplied by negative 4, and whatever that is added to the corresponding element in row 3 to get a new row 3. Here we go. 1 times negative 4, that is negative 4 plus 4 is 0. Again, negative 3 times negative 4 is 12. 12 minus 1 is 11. Again, negative 4 times 2 is negative 8. Negative 8 plus negative 2 is negative 10. Last time, negative 4 times 5 is negative 20. Negative 20 plus 7 is negative 13. And that finishes our row operations for part B, and that's it for number 17. Number 18, find the indicated term of the given sequence. They want us to find the 121st term, and the sequence 6, 2, negative 2, negative 6, they give me no indication whether this is arithmetic or geometric or neither. So we really need to figure that out first. So what I'm going to look for first is a common difference. What would I have to do to get from 6 to 2? Well, that's easy. I would just minus 4. But does that work again? If I take 2 minus 4, do I get negative 2? And if I do negative 2 minus 4, do I get negative 6? And the answer is yes. So that indicates that there is a common difference, which indicates that this is arithmetic. So let's make a note. We know the first term is 6. That's given. And we also know the common difference is negative 4. So knowing the general term of the arithmetic sequence will allow me to find the 121st term. So taking the formula for the general term and doing a little plug and play, a sub 1 is 6. Remember, when you're writing the formula, n stays n, multiplied by the common difference, and then we're going to distribute and simplify. Negative 4 times n gives us a negative 4n. Negative 4 times negative 1 gives us a plus 4. We also have the plus 6. And then if I CLT, our general term becomes negative 4n plus 10. And now with this formula, we know that our n is 121. All we need to do is plug and play. So the 121st term is going to be negative 4 times 121 plus 10. And I'm going to use my calculator for that. Negative 4 times 121 plus 10 is negative 474. So there is our 121st term, and that's going to do it for number 18. Number 19, determine if the infinite geometric series converges or diverges. So since they tell me the series is geometric, I know there's a common ratio. And we have a formula to find that value. That is a sub 2 divided by a sub 1. So our second term is 2/35. We need to divide that by the first term, which is 1/7. Doing a little keep change flip. That's going to give me 2/35 times 7 over 1. And then if I simplify before I multiply, I can see that the value for r, the common ratio, is 2/5. Now, remember, for this sequence to converge, the value of r has to be between negative 1 and 1. And 2/5 is definitely less than 1 and bigger than negative 1, so the series converges. So the sum formula for an infinite geometric series is a sub 1 divided by 1 minus r. And plugging in, that's going to be the first term, which is 1/7, divided by 1 minus r, which is 2/5. And then if I want, I can plug that into the calculator, or I can do it manually. Let's do it by hand real quick. That's 1/7 divided by 1 minus 2/5 is 3/5. Keep change flip. And multiply straight across is going to give us 5 over 21, which is the sum of the infinite geometric series. And for the last problem on our Precalculus final exam review, they want us to use the binomial theorem to write out the binomial expansion. That means we're going to have to write out all of the terms that we would get if we multiplied this out. So it would be really nice if we had the binomial theorem, and I happen to know that. For a binomial expression, a plus b to the n, that formula is the sum, as k goes from 0 to n of n choose k, a to the n minus k, b to the k. And so plugging and playing into this formula, we're going to get the terms of our binomial expansion. Okay, so starting with k equals 0, we can see that n in this case is 4. So that's going to be 4 choose 0, a, which is 3x, to the n minus k, which in this case would be 4 minus 0. B is negative 5. That's going to be negative 5 to the k. And then we're going to put a plus because it is a summation. And then k increments. Next, 4 choose 1. 3x to the 4 minus 1. Negative 5 to the 1. Plus, and then k increments. 4 choose 2, 3x to the 4 minus 2, negative 5 to the 2. And then the pattern continues until you get to n, which is going to be 4 choose 4, 3x to the 4 minus 4, negative 5 to the 4. And then we need to calculate each one of those terms. All right, with our calculator, to do 4 choose 0, that's going to be 4 shift and divide. For the c, 0, that's going to give us a 1. So that'll be 1 times, and then I've got 3x to the 4th. So 3 to the 4th is 81. X to the 4th is, well, x to the 4th. And then anything to the 0 power is 1. So that'll be times 1, which I don't really need to write times 1, or this times 1 either. And so that's going to be the first term of our binomial expansion. Plus, and then we need to do the next term. So again, on the class whiz, 4 choose 1. That is going to be 4 times 3x to the 3rd. 3 to the 3rd is 27. X to the 3rd, well, is x to the 3rd. And then times negative 5, because negative 5 to the 1 is negative 5. Plus, and then we rinse and repeat. 4 choose 2. Gives us a 6. That's going to be multiplied by 3x to the 4 minus 2, which is 2. 3 squared is 9, x squared, and then multiplied by negative 5 squared is a positive 25. Plus, and then the next term that I didn't write, which would be 4 choose 3, which is 4 times 3x to the 4 minus 3, which is 1, would give us just a 3x, but then that would need to be multiplied by negative 5 to the 3rd, which is negative 125. Plus, and then the last term, 4 choose 4 is 1 times 3x to the 0, anything to the 0 is 1, times negative 5 to the 4th, which is going to be positive 625. And the last step, we need to simplify each one of the terms of the binomial expansion, and this will be our last step. 81x to the 4th is already simplified. Next, 4 times 27 times negative 5 on the calculator. 4 times 27 times negative 5, negative 540. That is going to be the coefficient of our x cubed. and then plus 6 times 9, 54 times 25. 54 times 25 on our calculator, 1350. So 1350 is the coefficient of x squared, and then minus, because I can see these terms are alternating, 4 times 3, which is 12, times negative 125, 12 times negative 125, negative 1500. That is the coefficient of x. And last but not least, we have the constant, which works out to be just 625. And that's going to be our binomial expansion, simplified completely. And that's going to do it for this particular problem, and that finishes up our final exam review. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me, and thanks for watching.